math students, this video is to help you with your focus notes assignment for Algebra 1B Unit 2. So you've done one of these assignments before, so I'm not going to go through the directions in as great of detail this time because you should already know what you're doing. But make sure when you're watching this video that you've already printed off this paper so you can fill it in as we go through this video. And then when you're done, you're going to take a picture of it and submit it. So just follow along and fill it in as we go. So the essential question, how can you tell the difference between exponential growth and exponential decay? So we're not answering this question right now. This is just the question you should be thinking of as we go through all of these notes. The initial question, making it a little bit more specific. What is exponential growth? What is exponential decay? So we are going to figure out what those things are. Again, we're not going to answer this question right here. We're just going to list some sources. Where can we find the answer to this question? What is exponential growth and what is exponential decay? So usually you're going to want to go back to your course and find the lesson about those things. So here's your course. This is in lesson 8. So we have in workbook 8.1, there was exponential growth. In workbook 8.2, we had exponential decay, and then we had some growth and decay in context. So I would say all of lesson 8. So on my paper, on my focus notes assignment, I'm going to write lesson 8. And then specifically 8.1, 8.2, and 8.3 were kind of the subtopics that talked most about exponential growth and decay. So now I know where I can find some information about this. So the next part is the vocabulary. So like we did last time, we're going to go find these words in our lesson and we're going to write out the definition and possibly some numeric examples that go with it. So going back to the course, we want to start with exponential growth since that's the first one on the focus notes assignment. Usually you can find these vocab terms quite quickly in here because they are underlined and they're usually a different color. This is loading. Okay, so exponential growth. So right here it says exponential growth is a set of increasing values that can be described using an exponential function. So you want to take a minute and write that onto your vocabulary section in your notes. You can pause the video now to do that. So exponential growth is a set of increasing values that can be described using an exponential function. The other thing I want you to write in there is this general formula for an exponential function. So I'm going to write it over here. I'll go back to my paper here in a second and show you what I'm writing. So I just wrote down this general formula here too. You should have just written out your exponential growth formula. I just don't want to take up all the video time writing that out for you. So here's the general formula. We're going to need to refer to that for exponential growth and exponential decay in just a minute. So I wrote that off to the side, so make sure you do the same. So going back to the lesson here, I'm going to scroll down a little bit more. So we have some examples. Okay, so right here in this blue box, key concepts and idea. Exponential growth problems will always involve a growth factor, or B, that is greater than 1. So that is so important that we know that on our paper here, that for exponential growth, B is greater than 1. So make sure you write that as part of your definition. B is greater than 1. That's how we can tell by looking at a function if it's exponential growth or not. So for the exponential growth, this number, whatever's in there for B, is going to be greater than 1. Okay, now exponential decay. So I'm going to go back to the lesson here. So this whole lesson was about exponential growth. So I'm not going to be able to find exponential decay in here. So if I go to the next part, the next lesson was exponential decay. So I'm going to scroll down here and find exponential decay. Okay, so exponential decay. So similar in this blue box here, exponential decay problems will always involve a growth factor, or B, that is between 0 and 1. So very important that we know that. We're going to go back to our paper here, and in our definition for exponential decay, we're going to say B is between 0 and 1. That doesn't mean it's negative, right? Between 0 and 1 is like a decimal or a fraction, something between 0 and 1. For example, we could have something like 0.32. That's an example of something between 0 and 1. So just so you can wrap your head around that. And our last thing here is function. Because we're talking about all of these things, function, I would actually just move this whole thing right down here as our definition for function in the exponential growth and decay category. So this is what the exponential functions look like, and then we can determine from there whether it's exponential growth or exponential decay. All right, so now let's apply some of that knowledge that we just wrote down there. So applying what you know, here's an example, and it's just asking you, what is the growth factor, or b, in this function? So remember, here's the general formula. We just wrote this down because we knew it was going to be so important. So we just need to identify what is the b here. So this one doesn't have like a plus k off to the side. That's okay. That just means like this would be something plus 0. There's not always that plus or minus off to the side. That's okay. So just keep that in mind as you go through. So I'm going to give you an example that's not written on your paper because I don't want to give you all the answers here. Let's pretend this was the problem you had written on your paper. Again, you don't need to write this down. This is just me talking this out with you. If I was trying to figure out what the growth factor is in this equation, or in this function, I would look for the thing that is raised to the exponent of x, the term that is raised to the exponent of x. So right here, it would be 6. So I would say b equals 6 in this function. Now you take a minute and answer the question about the problem listed on your paper. So you can pause the video if you want and answer this question. What is the growth factor in this function, the one printed on your paper, and then write that answer right here. Second example, we're going to do the same thing. We're going to figure out what is the growth factor, or b, in this function. I'm going to make up a new one because I don't want to give you the answer to yours. I'm just going to make up one here. So if I was answering the question about this one I just made up, what is the b, the growth factor in this function? Again, I'm going to look for the term that's raised to the exponent of x. So my growth factor, my b, would be 2/3. So if I was answering it, I would say b equals 2/3. But now you're going to take a minute and answer the question that's printed on your paper. So take a minute, pause the video, and answer, what is the growth factor, or b, in this function? So now that we've kind of taken a small look at those problems, we're going to actually answer the bigger question. Does this function represent exponential growth or exponential decay? So remember on that first page we just talked about, it's exponential growth if the b, the growth factor, is greater than 1. And it's exponential decay if it's between 0 and 1. So once you've identified your b, which you just did that on the previous question, you figured out what your b, your growth factor, was. Now you can say it's either exponential growth or it's exponential decay, and make sure you answer this why. Why is it exponential growth or decay? So for the example that I did back here, I would say this is exponential growth because the b value is greater than 1. Now you're going to answer that for your question. Is this exponential growth or is it exponential decay based on that b value? And you're going to do the same thing over here. You're going to say this is exponential, whatever you decide, growth or decay. And why? Because the b, the growth factor. So answer that question. Go ahead and pause the video now and actually answer that full question. All right, here's 2 more for you to try. So now you're going to just do the whole thing. We didn't break it down piece by piece. Does this function represent exponential growth or exponential decay? So again, to figure this out, you're going to be looking at that b value, what is raised to the power of x? That's our growth factor. That's our b. Is it greater than 1 or is it between 0 and 1? That's how we decide if it's growth or decay. So take a minute, pause the video, and write down what you think. Is it exponential growth or is it exponential decay? Same thing here over on this question. So we have this function. The question says, does it represent exponential growth or exponential decay? So to figure that out, I have to look at that b value, the number that's raised to the exponent of x. Is this number greater than 1? Or is it between 0 and 1? That's how you can tell if it's growth or decay. So take a minute, pause the video, and answer that question. Last step on all of these focus notes assignments is to reflect and summarize your answer to the essential question. So way back at the very beginning of the notes, our essential question, what we were trying to figure out is, how can you tell the difference between exponential growth and exponential decay? So hopefully going through these examples helped you to be able to answer this. How can you tell the difference between exponential growth and exponential decay? You're going to write this out in complete sentences, but remember, exponential growth was where we had that b, that growth factor was greater than 1. And the exponential decay had b between 0 and 1. So you want to make sure you include those in your answers here that you're going to write out in complete sentences. Those are very important keys there. And then how can this knowledge be applied to solving future problems about exponential growth or decay? So now that you know that, how does that help you? What will you be able to do now? And now remember, right after this video, you're going to be doing a Flipgrid video explaining what you just learned on this focus notes assignment. You can also respond in writing if you really don't want to do a video, but we love seeing those Flipgrid videos so we can hear you walk or talk us through it and hear your thinking. So that is the focus notes assignment for Unit 2.